In this presentation, we're going to look at the binomial probability distribution, and in this instance, we're going to look at a worked example concerning a multiple choice question exam. Suppose that the student is taking a multiple choice question exam in which there are 4 choices. Suppose that she has no knowledge of the correct answer to any of these questions, and furthermore, suppose that she selects one of the possible choices at random as her answer. Okay, so fair play to her. I've been known to do that myself the odd time, so I'm not going to judge. Anyway, we'll move on. Exercises. A. If there are 5 multiple choices questions on the exam, what is the probability that she will answer 4 questions correctly? B. What is the probability that she will answer none of the questions correctly? And C. What is the probability that she will answer at least 2 questions correctly? So straightforward enough. So exercise A. Calculate the probability that she will answer 4 questions correctly. So let's just set up our scenario here. So each question has 4 choices. So the probability of selecting the right choice as your answer is P 1 over 4. We do know that P, and the probability of P is 1 over 4. The probability of answering a question incorrectly is 1 minus P, and that is obviously 3 over 4. Okay, just remark that in some books they denote the complement of a success probability by Q. So 1 minus P actually might be Q. Okay, anyway, we'll just stick with what we have here. 3 over 4. 1 minus P is 3 over 4. And there are 5 questions in total, so n is equal 5. There's 5 independent trials. So we have our probability mass formula here. Probability of x equal k equals n choose k from n choose k times the probability of times p to the power of k times 1 minus p to the power of n minus k. So n is the number of trials, which I said before is 5, the number of questions. K is the number of successes, i.e. correct answer, which is 4. And p is the probability of success, which is 1 over 4. Now just going back to the first term on the binomial probability formula, n choose k, that is a binomial coefficient. If you're not familiar with how they work, I'm not going to cover them here, so just go back over that and look at binomial coefficients, okay? So anyway, the probability that she answers 4 questions correctly is as follows. Probability of x equals 4 is 5 choose 4, which is 5. 1 over 4 to the power of 4, which is 1 over 256. And 3 over 4 to the power of 5 minus 4, which is 3 over 4 to the power of 1, which is 3 over 4. Okay, so what we're going to do is multiply out all of those numbers together. 5 times 1 over 256 times 3 over 4, which is 15 divided by 1024, which is approximately 0.0146%, 0.0146, 1.46%. So the probability that she answers 4 questions correctly is approximately 0.0146. So less than 1 in 60, probably 1 in 70 or something like that, probability. Okay, not impossible, you know. Exercise B. What is the probability that she will answer none of the questions correctly? Okay, so again, we use the same formula, but here we have k equals 0, okay? And n minus k, therefore, is 5 minus 0, okay? So 5 choose 0 is 1, okay? From 5 choose 0. 1 over 4 to the power of 0 is 1. And 3 over 4 is to the power of 5 is 243 divided by 1024, which is approximately 0.2373, 23.73%, okay? So the probability that you will answer no question correctly is approximately 0.2373, or 23.73% if you prefer. Now, probability that you will answer at least 2 questions correctly. So again, when you're asked these questions, when you see at least, just think about that carefully. So usually this is an indicator that you should use the complement. Okay? So what we're going to do is find the probability of x less than or equal to 2, which is the complement of x greater than 2. Okay? And so what we're going to do is find the probability of x less than 2, which is probability x equals 0 and x equals 1. Okay, it's the complement essentially. Now we've already calculated the probability of x equal to 0. So what we have to do now is calculate the probability of x equal to 1. The probability of x equal to 1 equals 5 choose 1, which is 5, 1 over 4 to the power of 1, which is 1/4, and 3 over 4 to the power of 5 minus 1, which is 3 over 4 to the power of 4. Working that out, 3 over 4 to the power of 4 is 81 over 256. So essentially we end up with 5 times 1/4 times 81 over 256, which is 405 divided by 1024, which is approximately 0.3955, 39.55%. So the probability of x less than 2 is the answer from exercise B, which is 23%, 0.2373, plus the probability of x equal to 1, which is 0.3955. So together, that is 0.6328. So we want to find the complement of that, okay? X is at least 2. So we subtract that value from 1. So we have 1 minus 0.6328, and that is 0.3672. So the probability that you will answer at least 2 questions correctly is 0.3672. And that is it. So again, just a reminder that the key thing there is just to get the hang of binomial coefficients beforehand.